Hello everyone, welcome to the second part of the time, speed and distance cheat sheet. In the first part, we have already looked at 4 of the 6 concepts that are important from the perspective of time, speed and distance. So we went through the basic formula, we went through the concept of average speed, we went through the concept of relative speed, and we also covered a bit of linear motion and circular motion. If you haven't watched that video already, do make sure that you have a look at that video. I'll put the link to that video in the description box below. Now coming to the topics of this video, we are going to look at the topics of races and also upstream and downstream motion, which also includes escalators. Now to start with races, it's a very basic concept wherein multiple participants are there who will start together and they will try to finish one before the other. So if you are a winner or if you intend to win the particular race, you will want to beat someone by a certain amount of distance or by a certain amount of time. Now we'll cover these two concepts a bit later in this video, but to start with, we have to understand these concepts of draw, dead heat, tie and deadlock. All these concepts mean the same thing, that all the people will finish the race at a certain point in time. Now what can happen here is everyone might start at the same time and might end the race at the same time, or they might start at different points in time. Now head starts is what the different points in time concept looks like. So let's say for example you are racing against your kid cousin, your kid brother or your kid sister. Now you would not want to overpower them and start winning right from the start. So what you will do is you will try to give them an advantage, meaning that you will allow them to start a bit earlier and then you will start the race. So that is basically the concept of head start, and they have to be discounted for relative speed. Now what do I mean discounted for relative speed? It basically means that whenever you are trying to figure out at what speed are you overtaking or are you trying to cover the gap between you and your opponent, is nothing but the relative speed that exists. But this relative speed will come into action only when all of you or both of you are traveling together. So let's say you give a head start to someone by 10 meters, then for the first 10 meters, your opponent will be the one who will be running the race. But after 10 meters are up, then you will start running the race together. And that is basically when relative speed will come into the picture. So that is one thing you have to keep in mind. Now, there are a couple of things that you have to remember, as I had previously mentioned. The first thing is, if the winner wins by some distance, then the time taken is constant. Now, this is a much more mainstream case that exists, that 2 or more people will start at the same point in time and they will finish the race such that the winner will finish the race, and at that point in time, there will be a snapshot taken. Now that snapshot will tell you that the winner has won the race, and at the same point in time, the opponent would be some distance behind the winner. Now for all practical purposes, there are 2 snapshots that were taken. One at the beginning of the race, one at the end of the race, which means that the time taken between these 2 snapshots would be constant, which means that you and your opponent have been traveling for the same amount of time. But the distance that would have been covered would be different, and the gap between these 2 distances will be the amount by which the winner would have won the race. Now in these cases, the time taken is constant. So let's try to see with the help of an example, how do we resolve these kind of questions. Now we already know that when time taken is constant, distance will be directly proportional to speed, and we have to use that concept when it comes to solving this particular question. So let's say in a 100 meters race, A beats B by 10 meters and A beats C by 19 meters. By how much distance will B beat C? Now in this particular context, if you look at the entire story that we have here, we know that because A beats B by 10 meters, we know that the time taken is going to be constant, which means that distance is directly proportional to speed. So in this context, if you look at the first case, you will see that dA upon dB, distance covered by A divided by distance covered by B, will be the same as speed of A upon speed of B, because we know distance is directly proportional to speed. In the second case, we know that dA by dC is equal to SB by SC. Now in this context, if you just plug in the values, you will be able to understand what is the ratio of SA by SB and SA by SC. So from the given data, we know that A beats B by 10 meters, meaning that when A covers 100 meters, B would have been 10 meters short, or B would have covered 90 meters. So speed A or speed A by speed B is going to be 100 by 90, and similarly speed A by speed C is going to be 100 by 81, because C has been beaten by 19 meters, C would have already covered 81 meters. Now from these 2 expressions, we can figure out the ratio of SB and SC. So if you divide the first equation by the second equation, you are going to get the value of SB by SC, and that will be equal to 90 by 81. This essentially tells us that for every 90 meters that B covers, C would have covered 81 meters. But when do we say that B would have won the race or B would have beaten C? When B would have completed the race. So when B would have covered 100 meters, C would have covered 90 meters. Or in general, you can say that B beats C by 10 meters. Now there is a very small thing that you can observe in this context as well. We can see that in a 100 meters race, A beats B by 10 meters, which basically means that B is 90 meters or B has done 9/10 of the race. We also know that at the same point in time, C has covered 81 meters or C is 9 meters behind B. Now you can also think about it like this. 90% of the race is done and B is ahead of C by 9 meters. What if 100% of the race would have been done? Then B should have been ahead of C by 10 meters. And that's why B should have beaten C by 10 meters as well. So you can also do this visually or orally. Let's look at the second concept that we have here. If the winner wins by some amount of time left, then the distance covered is constant. Now what does this mean? Both the people who are racing this particular race start at the same point in time. Both of them end the race. Both of them finish the entire distance that was supposed to be covered during the race. So think about it like a marathon. But what happens here? The winner would have reached the end point and would be waiting for some amount of time for the opponent to reach the end point. And that is the amount of time by which this person would have won the race. So if the winner wins by some amount of time, both the winner and the opponent would have covered the same amount of distance. And when distance is constant, you know that speed is inversely proportional to time. Let's try to see it with the help of an example here. So in a 400 meter race, runner A finishes 6 seconds ahead of runner B and 10 seconds ahead of runner C. If runner B runs the race at an average speed of 8 meters per second, what is the average speed of runner A and by how many seconds does runner B beat runner C? Very easy question. Now first thing, if you look at it, we are talking about by how many seconds does runner B beat runner C, which means runner B would have completed the race and now runner B would be waiting for runner C to complete the race. We know that B finishes or A finishes 6 seconds ahead of B, which means that B would be finishing 6 seconds later and C finishes 10 seconds later, which basically means that B would have been waiting for C for 4 seconds to finish the race, and that's why B would have beaten C by 4 seconds. The second part is again very easy to manage. We know that the speed of A is, or speed of B rather, is 8 meters per second, but B is going to cover 400 meters. So B would have covered 400 meters at the speed of 8 meters per second in 50 seconds. But we know that A beats B by 6 seconds, which means that A would have covered the same distance in 44 seconds. And A has covered 400 meters in 44 seconds, and that will give you the speed of A as 400 by 44 or 9.09 meters per second. Now we will move on to one small tricky question that I had from the concept of races. Think about it like this. It's a 100 meter race. A gives B a head start of 10 seconds and A wins by 5 meters in this case. In the second case, A gives B a head start of 10 meters but still wins by 5 seconds. We have to find out what is A's speed. Now if you look at it in the form of equations, you will see that first case A takes t seconds to cover 100 meters, let's say. Then B would be taking t plus 10 seconds because A has given B a head start of 10 seconds, meaning that B would have joined the journey or started the journey 10 seconds earlier, and then B would have also been traveling for t seconds. So B would have been traveling for t plus 10 seconds. But does B finish the race? No. B is still losing by 5 meters or A is winning by 5 meters. So we can say that B would have covered 95 meters in t plus 10 seconds. Case 2, A takes t seconds again to cover 100 meters. But now B is taking t plus 5 seconds because B loses by 5 seconds, which means that after A has reached the end point, B will take 5 meters or 5 seconds more to finish the distance. So B will take t plus 5 seconds to cover 90 meters because A has given a start of 10 meters to B. So B had to cover 90 meters. B is able to cover those 90 meters, but he's taking 5 seconds more than what A has taken. In both the cases, we know that speed of B remains the same. So we can say that what happens in case of case 1, speed B is given by nothing but distance B upon time B. Distance covered by B in the first case is 95, time taken by B is t plus 10. In the second case, distance covered is 90, time taken is t plus 5. Now in this case, what we are going to see, 95t plus 95 into 5, if you do cross multiplication, will be 90t into 90 multiplied by 10. If you just shuffle all the terms, you will see that t is 85 seconds. Now how do you figure out speed of b? We know that speed of b is going to be nothing but either 95 divided by t plus 10 or 90 divided by t plus 5. If you know that t is 85, you can just put t equal to 85 here and your answer will be 95 divided by 95, that is 1 meters per second. Now, of course, there has to be a shorter solution to this. So let's try to explore what is the shortcut here. Exactly the same question. Now you have to think about it in these slides. Case 1. What was the advantage that was needed by B to finish with A? If B wanted to finish with A had given B a head start of 10 seconds. So B needed that advantage of 10 seconds. And also B needed another advantage of 5 meters. So B needed a total advantage of 10 seconds plus 5 meters to start with A and finish with A. Similarly, in the second case, the advantage needed by B to start with A and finish with A for the same race was 5 seconds. So A wins by 5 seconds, which basically means if B had another 5 seconds advantage, B and A would have finished together. Also, A gives B a start of 10 meters. तो वो भी advantage उसको चाहिए. So together, if you look at it, advantage needed by B to finish the race was 5 seconds plus 10 meters. दोनों जगह पे advantage same होना चाहिए because A and B are running the same race and we are saying that in both the cases, both of them should start and end at the same point in time. That tells us that for B, the advantage needed was 5 meters or 5 seconds, which basically is the same thing, which means that B is traveling at a speed of 5 meters per second or 5 meters in 5 seconds or 1 meter per second. Now we'll move on to the second concept, that is upstream and downstream motion. This is a fairly straightforward concept. We can also call it boats and streams concept. With the stream, if a boat is traveling, the effective speed is going to be the sum of the speeds because the stream will enhance the speed of the boat. So both of them are independent entities that we have here. And because these two are independent entities that we have, what will happen is if the boat is covering, let's say 5 meters per second and the stream is moving at a speed of 2 meters per second, in 1 second, the stream would have already moved ahead by 2 meters and the boat would have moved ahead by 5 more meters. So together they would have covered 7 meters per second. So when two objects or an object is moving along with the stream, we will always add the speed of the stream to that of the boat or the object. Similarly, the motion will either be in one of the two directions that is there, which basically means that whenever someone is telling you that along a river A and B start moving towards each other, it is not going to be from the opposite banks that they are going to start moving together. They will start moving together from maybe two podiums that are there in the middle of the stream. They will both jump into the stream from there and one of them will be traveling along the stream, another person will be traveling against the stream. Speaking about against the stream, whenever someone is traveling against the stream, the effective speed or the relative speed is going to be the difference between the speed of the object and that of the stream. Also, one very simple formula that you always have to keep in mind, total time taken. So if there is some person or some object or some boat that is at one point, it goes till another point and comes back. One of the directions will be upstream, the other direction will be downstream. Then we have to use this form. The total time taken is going to be time taken to go upstream plus time taken to come downstream. And in this particular context, if you are talking about the amount of time taken, it will be distance upon speed. So if the distance is, let's say, d between these 2 points, the time taken to go upstream is going to be d divided by b minus s, where b is the speed of the boat, let's say, and s is the speed of the stream. Similarly, time taken to go downstream will be d upon b plus s, because upstream we will subtract the two speeds against the stream and downstream we will add the two speeds because it is with the stream. So that is what we have to understand in terms of upstream and downstream. Also, speed upstream is speed of object minus speed of stream, and speed downstream is speed of object plus speed of stream. Now there is a very small tricky question that we have in this particular context. So have a look at this. There's a shortcut that is involved here. It's a very interesting question. What I would suggest is you pause the video, have a look at the question, try it out on your own. Let me know in the comment section below what you think about this particular question, and then have a look at the shortcut that is going to follow. Now A was going in a boat when her cap fell into the water and started floating back downstream. The boat kept on moving upstream for 12 more minutes before A realized her cap was missing. She then turned back and caught the cap when it reached the starting point. If her cap had fallen into water 3 kilometers away from the starting point, find the speed of the current. Now, I know a lot of people might get into this situation when they will say that let the speed of the boat be B, let the speed of the stream be S, let A be the point where they had started, let B be the point where the cap had fallen, let C be the point where she realized that the cap had fallen, and then try to equate the distances that are there. And then you can solve it. Of course, you will be able to solve it using that method. So those of you who solved it using this method, do let me know in the comment section what were the equations that you came up with. But there's a shorter way of doing this. And you have to bring together the concepts of upstream, downstream, and relative speed / effective speed to answer this question. So understand this part. If the speed of the boat is B, so let's say we are talking about that part of the motion wherein the cap had fallen off. And now the boat is continuing to move upstream and A does not know that the cap has fallen off. Now, if A is continuing to move upstream and the cap is moving downstream or along the stream, that's what we are trying to say here, then at what speed will the gap be getting created between these two objects? We know that the boat is going upstream, so the speed of the boat is going to be B minus S in this context. We know that the cap is traveling along the stream and the cap does not have any speed of its own, so it is traveling at a speed of S. Now we can say that because the boat is traveling at a speed of B minus S and the cap is traveling at a speed of S in the opposite direction, the gap that is going to be created is going to be the sum of the two speeds. So B minus S plus S kilometers per minute. I have taken the units as kilometers per minute because that is what the question says. So effectively, the gap that is being created is at a speed of B kilometers per minute. But this motion is going on for 12 minutes. So in 12 minutes, the gap created will be 12 B kilometers. Now what happens? Now the boat realizes that the cap has fallen and both of them start traveling in the same direction now. The cap will cover some distance and the boat will cover some distance in the same amount of time that we have. Now again, you have to understand this gap of 12 B kilometers has been created. This gap of 12 B kilometers now has to be entirely filled. Now, how will you overcome this gap of 12 B kilometers? Again, we have to think about the relative speed of the boat and the cap. Now, again, if you think about it, when the boat is going downstream, the speed of the boat is going to be, or the effective speed or the relative speed of the boat is going to be B plus S because it is traveling along the stream. The speed of the cap is S, but both of them are moving in the same direction. So, considering relative speed here, B plus S minus S will basically be the amount of speed at which this gap is going to get covered. So now this gap is going to be covered at a speed of B plus S minus S, that is B. The gap is of 12B and it is being covered at a speed of B plus S minus S, that is B kilometers per minute. So how much time is it going to take? 12 minutes again. So now the boat has been in motion for 12 plus 12, that is 24 minutes, which basically means the cap also has been in motion for 24 minutes. The cap has fallen into the water 3 kilometers away from the starting point and it reaches the starting point at the end, which basically means that the cap would have covered 3 kilometers in 24 minutes, or the speed of the stream is going to be 3 kilometers every 24 minutes or 7.5 kilometers per hour. Do let me know if you have understood this shortcut, and if you haven't, again let me know. I'll try to explain to you in slightly simpler words and you should be able to get this part. Moving on to the last part of the video, escalators is a fascinating concept, and from the point of view of CAT, we see some questions here and there on and off once every 2 or 3 years that we get from the concept of elevators. Now, in terms of escalators or elevators, we can call it escalators because they involve steps. Elevators, on the other hand, are the lifts that are present. We are always thinking about speed in terms of steps per unit time. So you'll always get the units of speed in terms of steps per minute, steps per second, and so on. Now the distance will always be in terms of steps. So if it is a stationary escalator and you can see 20 steps that are supposed to climb, that will basically be the distance. So we are not talking about distance in terms of meters or kilometers or centimeters or whatever. We are talking about distance always in terms of steps. In this case, if an escalator is moving at a speed of S steps per second and a person is moving at a speed of X steps per second, effectively the person will travel X plus S steps per second if the person is going with the escalator. If the person is going against the escalator, then the person will have to overcome the number of steps that the escalator is taking, counter it, and then do extra work, which basically means the person will be traveling at an effective speed of X minus S steps per second. Also, we have to understand these two parts, and once we understand these two parts, we should be able to solve the questions that are there. Now there are a couple of questions that we will discuss to understand how escalators function. This is a CAT 2022 question. Moody takes 30 seconds to finish riding an escalator if he walks on it at his normal speed in the same direction. So जिस डायरेक्शन में एस्केलेटर जा रहा है उसी डायरेक्शन में अगर मूडी चलता है, then Moody takes 30 seconds to finish riding an escalator. He takes 20 seconds to finish riding the escalator if he walks at twice his normal speed in the same direction. तो अगर एस्केलेटर के डायरेक्शन में ही चल रहा है बट उसने अपना स्पीड डबल कर दिया तो 20 सेकंड्स में पहुंच जाएगा, which is obvious. You increase the speed, you will take less time to reach the destination. If Moody decides to stand still on the escalator and let the escalator do the entire work, then the time in seconds needed to finish riding the escalator is what? Very straightforward question. हम लोग start करते हैं. Speed of escalator, let it be s. Speed of Moody, let it be m. Now what is happening in the first context? 30s plus 30m का मतलब क्या हो गया? 30 seconds तक Moody is walking, but the escalator is also working for 30 seconds. Na? So if you are saying that the speed of escalator is s steps per second and speed of Moody is m steps per second, then in 30 seconds distance कितना cover किया होगा? 30s plus 30m. 30s by the escalator, 30m by Moody, and together they are covering the entire distance. Na? He is reaching the top by being in motion for 30 seconds. अब अगर वो twice his normal speed पे जाता है, even then he is covering the same amount of distance that he had covered in the first case, क्योंकि escalator पे है तो उतने ही steps. So in this case, what is going to happen is the escalator would be functional for 20 seconds. So 20s would be the distance contributed by the escalator. Distance is speed into time, and 20 into 2m. Now the speed is twice. So 20 into 2m will be the distance covered by Moody. So in total अगर इसको देखा जाए अपने को पता चलेगा that 10s equals 10m और s equals m. इसका क्या मतलब बना? The speed at which the escalator is running, that is the same amount of speed at which Moody is also walking along the escalator. Normal speed जो Moody का है वो m है. तो s is equal to m, whatever will be the distance that will be there. Now we have been asked the amount of time that will be taken in seconds to finish riding the escalator. अब escalator पे steps कितने हैं? We have seen that 30s plus 30m is the distance and 20s plus 20 into 2m is also the same distance. ये distance क्या है? That is nothing but the number of steps on the escalator. So if you use s equal to m, you will see that the number of steps will be given by 30s plus 30m, that is 60s. Now 60s steps are there and they need to be covered at a speed of s. So time taken will be 60s divided by s is going to be 60 seconds. Very, very, very easy question. Let's look at the next question. On an upward moving escalator, A, B and C take 10 steps, 8 steps and 5 steps respectively to reach the top. Escalator चल ही रहा है. In the first case, when A is walking, the escalator is functional for 10 seconds or till the time A takes 10 steps. Second case के अंदर जब B 8 steps लेता है उतने ही time के लिए escalator is functional, and when C takes 5 steps उतने ही time के लिए the escalator is functional. On the same upward moving escalator, now A takes 30 steps to come down from the top. तो वो against the escalator काम कर रहा है. You have to find the ratio of the time taken by B and C to reach the top. Again, not a difficult question. If you understand and you can put it on your paper as to what you have read here. The first thing you have to do is you have to assume some variables. So let's say that the speed of A, B, C and the escalator be A, B, C and S respectively. Simple हम लोगों ने variables ले लिया. Now, if you look at the journey of A important है ना यहाँ पे. तो A की journey अगर देखते हैं हम लोग first time में, when A takes 10 steps, right? A takes 10 steps. A ने कितने टाइम के लिए ट्रैवल किया होगा? It is very important for us to understand for how much time has A traveled. Because ये अगर पता होगा, then you will be able to figure out कितने टाइम के लिए the escalator would have been functional. Because the escalator would have been operating for the same amount of time that A would have been moving. So in this particular context, A ने 10 steps लिए at a speed of A steps per second, let's say. Then what will happen in this case? A would have been traveling for 10 by A units of time. If A has been traveling for 10 by A units of time and speed of escalator is S, speed into time करेंगे तो अपने को मिल जाएगा distance. So in this case, the escalator would have taken S into 10 by A. Amount of time taken by A is the same as the amount of time taken by the escalator. ये याद रखना है. In the second case, when A takes 30 steps but now against the escalator, doesn't matter, escalator ने कितना step लिया होगा उतने time में? A will take 30 steps in 30 by A seconds or 30 by A units of time. So escalator would have taken S into 30 by A steps. Now what will happen? we know that in both the cases the distance remains the constant. Escalator पे है तो उतने ही steps. In the first case, the effort of A is combined with that of the escalator. तो क्या होगा? 10 हो जाएगा. A ने लिए हुए steps, उतने ही टाइम में escalator has taken S into 10 by A, तो ये बन जाएगा the amount of effort that is put in by the escalator. सेकेंड केस में क्या हो जाएगा? 30 steps have been taken by A, but A ने opposite direction में steps लिए हुए हैं. So whatever work the escalator would have done in the same amount of time would be negated. So total number of steps कितने बनेंगे? 30 minus S into 30 by A. अब इसको अगर हम सॉल्व करते हैं, यू आर गोइंग टू गेट 20 विल बी इक्वल टू 40s बाय A और 40s इक्वल्स 20A और A इक्वल्स 2S. ये अपने को मिल जाएगा. If A equals 2S, you can again put the value of A in any of these two equations or expressions that we have on either sides of the equality sign. And A को अगर 2S डाल देते हैं तो अपने को मिल जाएंगे total steps as 15. अब escalator पे है 15 steps. We know that B is taking 8 steps to reach the top. अगर B 8 steps ले रहा है तो उतने ही टाइम में escalator would have taken the remaining 7 steps. And अगर C 5 steps ले रहा है तो उतने ही टाइम में escalator should have taken 10 steps. Because 15 steps is what is required here. So we know that if we have to find the ratio of the amount of time taken by B and C to reach the top, we can look at escalator in both the cases क्योंकि वो constant है दोनों जगह पे. So when B is traveling, the escalator takes 7 seconds to reach the top or the escalator is functional for 7 seconds. And C के context में escalator is functional for 10 seconds. So we can say that the ratio of the time taken by B and C will be the ratio of the time taken by the escalator to cover 7 steps and 10 steps, which basically means 7:10. So that is going to be the answer to this particular question. I hope you had fun learning about time, speed, distance across these two videos. Do let us know in the comment section what you thought of the video and if you have some ideas for the upcoming sessions. And there is one small surprise for you, and this is the question that you have: are you scared of geometry? If you are, let me know in the comment section again, and I'll try to create something similar for geometry as well for your use. Make sure that you're subscribed to the channel and you have turned all the notifications on so that you get to know whenever a video is uploaded. Do like this video if you found it to be useful, and do share the channel and the video with any of your friends whom you think will benefit from this entire initiative.